Now, don't forget where we stopped. This is a SS1 class. We were on covalent bond. Covalent bond. And we have talked about single covalent bond, double covalent bond. I think we are now going to triple covalent bond, are we?
Yes, sir.
We are going to triple covalent bond. Chemistry. Triple covalent bond. Now, a triple covalent bond is formed when two participating atoms share three pairs of their valence or outermost electrons. When two participating atoms when they share three pairs of their valence electron. 3 pairs means 6 electrons. 3 electrons from part A from Mr. Man A, 3 electrons from Mr. Man B, making 6 electrons. That's 3 pairs of electrons. So there's a need for us to know examples of molecules with triple covalent bond. First is nitrogen. Second is ethyne, and so on and so forth. So let's start with nitrogen. This will be page 2 now. Let's start with nitrogen. Let's look at the example when it is nitrogen. So with nitrogen, formation of a triple covalent bond. In nitrogen gas molecule. Nitrogen gas molecule is denoted by N2. I've done that under atomicity, that elements whose name N in gene, the atomicity is what? 2. So the first, don't forget nitrogen is number what? Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7. And the configuration for 7 is 2:5, are they?
Yes.
So we now have nitrogen at the center. Then we are going to have 2 rings around the nitrogen. So that we have a 1:2:5. The 5 will now be 1, 2, 3, 4, then pair this one, 5. So if this one is combined with another nitrogen, is 1, 2. 1, 2, 3, 4, then pair this one, 5. This is yes. Huh? What? Okay. So now we have this. This is nitrogen atom, which is 2 to 5. This is another nitrogen atom, which is another 2 to 5. So if we now combine them, we are going to have this. Let's bring them together. The first one, the second one, nitrogen here, nitrogen here. This is 2. 1, 2. 1, 2. This is for these two. Then outside you have 5. For this one to form, this one will, out of the 5, 1, 2, 3, 4, 5. It donates 3. 1, 2, 3. It's left with how many? It's left with 2. After donating 1, 2, 3, it's left with these 2. Have it? Then the same thing. Out of 5 around here, it donates 3. 1, 2, 3. Then it puts 1 here. Are we together? So that when you now count around each of them, now you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can return that as triple bond between 2 nitrogen atoms. So we are through with that. That is triple bond in a molecule of nitrogen gas. Then the second one is ethyne. The formula for ethyne is C2H2. So if we have C2H2, so let's look at formation of a triple covalent bond in ethyne molecule, ethyne gas molecule. Ethyne, we have here 2 hydrogen atoms. This is the first hydrogen. Don't forget, hydrogen has only 1 electron, plus a carbon atom here. Carbon atom is 2 to what? 1, 2, 2 to 4. 1, 2, 3, 4. This is hydrogen atom. Hydrogen atom. This is carbon atom. Plus another carbon atom. 1, 2, 1, 2, 3, 4. Another carbon atom. Then plus hydrogen atom. You can see that I use the same symbol for this hydrogen and this hydrogen, ball and ball. Then the same symbol for this carbon and this carbon because they are the same thing. So bringing them together. This is the first carbon. This is the second carbon. Carbon, carbon. These 2 electrons, 1, 2, 1, 2. Then this one also forms triple bond. It out of 4 electrons here, it gives 3. 1, 2, 3. It's left with 1. You put the 1 here. Then out of 3 and 5 here, it gives 1, 2, 3. Then the last one is here. Then this hydrogen comes to form a single bond. A single bond with this. Are we there? This one not, and this hydrogen also comes here to form a single bond with this. So count around each of the carbon atoms. You have 1, 2, 3, 4, 5, 6, 7, 8. Around this one you have 1, 2, 3, 4, 5, 6, 7, 8. Around each of the hydrogen 1, 2. 1, 2. The 2 is filling K share for hydrogen. So we can write this one up as between this carbon and this carbon there is a triple bond. But between this carbon and this hydrogen there is a single bond. Between this carbon and this hydrogen there is a single bond. But between the 2 carbon atoms that are what? There is a triple covalent bond. I think we understand that. So then let's now look at general properties. General properties. Yes, sir.
The nitrogen, are they not 2 atoms? As nitrogen and nitrogen?
Yes, there are 2 atoms.
Triple covalent.
Is it not triple that is it? 1, 2, 3. That's triple bond now. They need 6 electrons to form triple bond.
Okay, it's about the valence.
Is the outermost electron, not we don't have this with the inside of it. Okay? So general properties of covalent compounds. General properties of covalent compounds. Yes, number 1. They are gaseous or volatile liquid at room temperature. What do we mean? All the examples of the citing other covalent bond, they are either gases, nitrogen gas. Water is a liquid. None of them is a solid. We see also that are solid, but they are free. So they are mostly gaseous, or if they will be liquid, that liquid will be light, volatile. What do we mean by room temperature? Temperature of the earth. You know, when we are enjoying now, when we did not put the thing on fire, or we did not put it inside the freezer, that's the room temperature. So, number 2, then they have low boiling and what? And melting point. You have low boiling and melting point. Number 3, that is when you put them on fire, it takes a shorter time before, if they are liquid, it starts changing to gas. It takes a shorter time if they are solid for them to start melting. So, unlike electrovalent, they contain molecules. Like we have a molecule of hydrogen. They contain molecule of element. Elements can have, like hydrogen now, the 2 atoms of hydrogen, H2, are the same. It can happen between the atom of one element and the atom of the same element. In electrovalent, it cannot be like that. It can either you have a metal or a non-metal, which are different elements. Atoms of different elements. Are we there? Like in nitrogen now, nitrogen and nitrogen are atoms of the same element. So they form a molecule of nitrogen gas. Are we there? So they can contain molecule. Then next one is that they are non-electrolytes. What do we mean by that? They are non-electrolytes. Why? As they do not ionize in water or in aqueous solution. And conduct electricity in the molten form or in solution. So they cannot conduct electricity in molten form or in solution. So unlike electrovalent compounds that we discussed before, but they are soluble. Why are they not soluble? They can dissolve in organic solvents. Organic solvents or non-polar solvents. You call them organic solvents or you call them non-polar solvents. So, I think you are copying this side, right? Okay. Now, let's look at number 6. They are insoluble. They can't dissolve in water and in other polar solvents. They can't dissolve in water because water is a polar solvent. They cannot also dissolve in other polar solvents. Now, quickly, let's look at the difference between electrovalent compounds and covalent compounds. Differences between electrovalent compounds and covalent compounds. Differences between electrovalent compounds and covalent compounds. Covalent compounds. Covalent compounds. So we are going to use their general properties that we have discussed before to differentiate them. The general properties we have discussed before. Under electrovalence, like your sodium chloride, the salt that you put your soup is solid, are they? Yes. So they are solid at room temperature. But these ones, they are liquid, they are gaseous or volatile liquid at room temperature. So, then number 2, you can use the property here. This ones have low, this ones have electrovalent. They have high boiling and melting points. But these ones, they have low boiling and melting point. Let me give you an example. If you put candle, you know candle is a covalent compound. Put it in fire and put sodium chloride, common salt, on fire. Which one melts faster? Candle melts faster because it has low boiling point. Which temperature can melt it? Are we together? So that is that. So then you are still continuing there. Number 3 now. Yes, we come here, we say this ones contain molecule. These ones electrovalence. They do not contain molecule. They do not, but these ones they contain molecule. So covalent compounds contain molecule, but electrovalent compounds or ionic compounds do not contain molecule. Now, number 4 here. Number 4, don't forget that we say these ones are non-electrolytes. So here, electrovalents, they are electrolytes. They are electrolytes. While these ones, they are non-electrolytes. So why are these ones electrolytes? Because they can conduct electricity in motive form or in solution. So here they are soluble in organic. So now electrovalents, they are soluble in water. Here they are insoluble in water and in other polar solvents. Some of you did not ask me what is polar. A polar solvent is a solvent that contains both positive ion and negative ion. And you know that water molecule contains hydrogen ion, which is positive, and negative ion, of hydroxide ion, which is negative. So that makes it polar. So these ones are insoluble in water. They are insoluble in water and in polar solvents. They can't dissolve in polar solvents. Then point number 6 there is that what? These ones, they are insoluble in organic or non-polar solvents. But these ones, They are soluble in organic or non-polar solvents. So that is that. So we are done with covalent bond, electrovalent bond. Do you have any question? Because we are going now to dative bond. We will likely end the class when we get to dative, when we are through with the dative bond. Okay. Oh, see me still like this again. Now, let's go to dative bond or coordinate covalent. Coordinate covalent bond or dative bond. We will look at this in the next video.